In this video, we'll be looking at 2.3, which is combined shapes. This can be found on page 53. First part of 2.3 is the perimeter of combined shapes. To do this, to find the perimeter, you simply have to add up all the edges, the lengths of all the edges that are on the outside. So for example, in this figure, A, B, C, D, E, you would have to add up AB plus BC plus CD plus DE plus AE. However, you do not add in AD for the perimeter because it's not found on the outside. If you're finding the perimeter of one of these shapes individually, you would include AD, but in this case you do not, since you're finding the area of the combined shape. The next section is 2.3.2, which is area. So to find the area of combined shapes, you simply have to add up all the areas of all the shapes that make up the combined shape. So for example, if you're trying to find the area of this pentagon, all you have to do is break it up into a bunch of rectangles and triangles that you can find the area of. So this, for example, you would do this. Then you can find the area of the triangles and this rectangle and add them all up, and that would give the area of the pentagon. So in this case, the area of pentagon ABCDE is equal to the area of ABF plus BHC plus CHD plus DGE plus a rectangle AFGE. The next problem, which is problem 2.5, is to find the area of this shape given that all of the edges of the square are equal to 3.5 centimeters. So first is to find the perimeter. So to find the perimeter, you first have to add up the area of each of these 4 arcs, and then add up the area of each of these 4 line segments. So first to find the arcs. So each of the arcs is a 90-degree arc in a circle, which has a radius of 3.5 centimeters. So each arc has a length of 1/4 times pi times 2 times 3.5. And since there are 4 arcs, you can multiply this entire thing by 4, so that to find the area of each one combined. This is equal to 7 pi. Now to find the area of the line segments. So each of these line segments is equal to one radius length of the square. So which means since each one radius is equal to 3.5 centimeters, the area is equal to 4 times 3. Since each has a length of 3.5 centimeters, the perimeter to 14 centimeters. So that means the combined area is 14 plus 7 pi centimeters, which is approximately 36 centimeters. Next is to find the area of this shape. So the area is equal to the area of each of the quarter circles plus the area of the square. So first we'll find the area of the square. So that's equal to, since the length of each side of the square is equal to 3.5 centimeters, the area of the square is equal to 3.5 squared, which is equal to 12.25 centimeters squared. Next is to find the area of the quarter circles. So each quarter circle is 1/4 the area of a normal circle, and the circle has a radius of 3.5 centimeters. Therefore, each quarter circle will have an area of 1/4 times pi times 3.5 squared. And since you're trying to find the area of each one combined, you're multiplying this by 4, since there are 4 quarter circles. And this is approximately equal to 38.5 centimeters squared. So then to find the area of this entire shape combined, you add 12.25 plus 38.5, and that gives approximately 50.75 centimeters squared. Next problem is to find the area of this shape, which is a equilateral triangle combined with a square combined with a semicircle. And each of the side lengths is 5 centimeters long. So first we're going to do the triangle. So the triangle, each side length is 5 centimeters. Therefore the area is root 3 times 5 squared divided by 4, which is equal to 25 root 3 over 4 centimeters squared. The area of the square is next. So each side length of the square is 5 centimeters. Therefore, the area of the square is equal to 5 times 5 equals 25 centimeters squared. Finally is the area of the semicircle. So the radius of the circle that the semicircle is 1/2 of is 2.5 centimeters. Therefore, the area of the semicircle is equal to 1/2 times 2.5 squared times pi, which is equal to approximately 9.81 centimeters squared. Then to find the area of this combined shape, you simply add 25 root 3 over 4 plus 25 plus 9.81, which is approximately equal to 45.64 centimeters squared. The next problem is to find the area of this shape. So this shape is composed of a trapezoid, right here, attached to a rectangle. So the area of a trapezoid is equal to 1/2 times the sum of the two bases times the height. In this case, this base has a length of 5 and this base has a length of 16, and the height is equal to 16. Therefore, the area of the trapezoid is equal to 1/2 times 5 plus 16 times 16, which is equal to 1/2 times 21 times 16, which is equals to 21 times 8, which equals 168 centimeters squared. Now to find the area of the rectangle. So this side length of the rectangle measures 16 centimeters and this side measures 8 centimeters. Therefore, the area is equal to 16 times 8, which is equal to 128 centimeters squared. Therefore, to find the area of the entire shape, you add 168 plus 128, which is equal to 296 centimeters squared. Next problem is as follows. A mat with this shape is being sold at 20 rupees per square foot. If each of the side lengths is as given, what is the cost of the mat? So the first step is to find the area of the mat. So first you have to split it up into two rectangles that you can find the area of. So you can draw a line like this. Now you have to find the side lengths of each of the rectangles. So the first side length is this side. Since this entire thing has a length of 7 and this has a length of 2, that means that this side measures 5 centimeters in length. Then you can find the area of this rectangle by doing 5 times 2, which is equal to 10 centimeters squared. The next step is to find the area of this rectangle. And since you know the side lengths, which are 9 and 2 centimeters, you can multiply them, and that gives 9 times 2 is equal to 18 centimeters squared. Therefore, the entire area is equal to 10 plus 18, which is equal to 28 centimeters squared. Next, to find the cost of the mat. Mat costs 20 rupees per centimeter squared. Therefore, to find the total cost, you multiply the cost per centimeter squared times area in centimeters squared. So the cost per centimeter squared is equal to 20 rupees. per centimeter squared. And then you know the area is equal to 28 centimeters squared. So the units cancel, and this is equal to 560 rupees. Next problem is to find the area of the shaded region in the diagram, given that each of the sides of the square is equal to 10 centimeters. To do this, you can break the square up into 4 different identical smaller squares. Then you can, this area, the area of this smaller square is equal to 25 centimeters squared, since each of the side lengths is equal to 5 centimeters. Then you can write the area in a different way by adding the area of the smaller square is equal to the area of this quarter circle plus the area of this quarter circle minus the area of the shaded region here. Therefore, so the area of the first quarter circle is equal to 1/4 times pi times 5 squared, which is equal to, or the area of the next quarter circle is the same thing, which is 1/4 times pi times 5 squared. And then you are trying to solve for the area of the shaded region is equal to x. So you subtract x. Then you can simplify this by writing this as 25 pi over 4 plus 25 pi over 4 minus x. Then you can combine these two terms, which gives 25 pi over 2 minus x. Then you subtract 25 pi over 2 from this side, you get negative x equals 25 minus 25 pi over 2. Then you multiply each side by negative 1 and you get x equals 25 pi over 2 minus 25. And this is approximately equal to 57.14 centimeters squared. The next problem is to find the area of pentagon ABCDE, given that this AF is 5 meters, EF is 6 meters, BG is 10 meters, FG is 8 meters, GH is 5 meters, HC is 8 meters, and DH is 4 meters. To this, you find the area of each of the smaller squares or rectangles and triangles and add them together. So first, the area of AEF is equal to 1/2 times AF is 5 and EF is 6, which means this is 5 times 3, which is equal to 15 meters squared. The area of ABG is equal to 1/2. AG is 5 plus 8, and BG is 10, which is equal to 1/2 times 13 times 10, which is equal to 65 meters squared. Next is BGC. This is equal to 1/2 times CG is equal to 8 plus 5, and BG is equal to 10. This is equal to 1/2 times 13 times 10 is equal to 65 meters squared. Last triangle is CDH, which is equal to 1/2 CH is equal to 8, and DH is equal to 4. And that's equal to 16 meters squared. So we have to find the area of trapezoid EFDH. So again, the area of the trapezoid is equal to base 1 plus base 2 times the height over 2. So in this case, base 1 is equal to 6, base 2 is equal to 4, since EF is the first base, DH is the second base, and then the height is equal to FH, which is equal to 8 plus 5, and then divided by 2. This is equal to 10 plus 13 over 2. 10 times 13 over 2, sorry. Is equal to 65 meters squared. Then all you have to do now is add up each of these areas to find the area of the total. This is equal to 15 plus 65 plus 65 plus 16 plus 65 meters squared. It's equal to 226 meters squared. That's the end of the video.